So we are actually about to go into Zoe's bedroom. There is a slight artistic mess, but our Zoe is drawing something. She is making a beautiful visual of Daddy. Tak, Zoe? Yeah. Beautiful visual of Daddy. I actually asked Zoe to draw Mama, Tata, and Zoe. Tak? Three faces, our family. No to narysuj Mama, Tata, and Zoe. So 3 family members. And she has decided to draw faces with eyes, with smiles, or something similar to a smile, with hair and arms. No dobrze, Zoe. Mama, Tata, Zoe. But Daddy has decided to draw something else. And this is a chart of the age of our 3 family members. Zoe is the youngest. On the y-axis we have the age, and then we have Daddy and Mommy. So 3 different people with different ages, right? Now, Zoe, kogo brakuje? Who's missing here? Kogo brakuje?
Baby.
Yeah, baby Lily. No to narysuj tutaj. Baby Lily, okay? And Daddy will actually add one more bar to this drawing. That is going to be a little bit smaller because Lily is the youngest family member. All right?
Baby.
Beautiful. Baby Lily. Yeah. So even though we have decided to draw the same thing, our family, 4 people in total, Zoe had decided to draw faces on a X and Y axis, with the face being the biggest for Daddy and smaller for Mommy and the smallest for Zoe and baby Lily. Daddy had decided to draw bar charts for different levels of age on the y-axis. Zoe, świetna robota, przyjmij 5. High five! Woohoo! The main purpose of that video, where me and Zoe were drawing the same thing, our family, on the whiteboard, was to show you that we can actually visualize the same thing in different ways. Zoe decided to visualize our family members by drawing heads, faces, for every single family member. The size of the head represented the height or the weight of the family member, right, Zoe? On the other side, I have decided to draw a bar chart to represent the age of all of our family members. So, same thing, but different aspects and different type of visualizations. There are many different types of charts. We have line charts, bar charts, scatter plots, maps, tree maps, you name it. And selecting the chart type really depends on the type of data that you are using and the message that you want to send, the insights that you want to be driving from your data. In this particular episode, we're going to be covering a scatter plot. The scatter plot is probably the most frequently utilized chart type. It is great for showing relationships, correlations, or causation between 2 different variables. We have the X variable and the Y variable. The focus for this episode will be learning about scatter plots and presenting those 2 variables together. So we're going to be using a data set called mtcars. mtcars is built in into your base R, so there is no need to install any libraries. If we actually go to our script, to our studio, and go into the first line and type in mtcars and press Command, Return, Control, Enter, we're going to get a beautiful data set in the lower left-hand corner with all of the cars and features of these cars. Their own names are the names of the cars in this data set, and then each variable is a different feature. We have miles per gallon, number of cylinders, horsepower, the number of gears, the weight, probably in tons. So many features. And in this episode, we want to see if there is any interesting relationship between these variables. So let's first use the most basic charting environment, the base rbase plot function. I'm going to use the plot function. Now, before I can use it, we need to understand what the arguments are for this function. So I'm going to do $plot and hit Command Return Control Enter, and then click the generic XY plotting. Okay, so the plot function here has a few arguments. It needs x and y. X is the x-axis coordinates, and y is the y-axis coordinates. So we have to tell R which variables you want to use to define our x and y axes. And then what's really important is to define the type of this chart. And as you can see, this plot function has a lot of different options: P for points, L for lines, P for both. What else? H for histogram, right? But in our case, we're going to be using P for points, and this P type will give us a scatter plot. So let's do that. Let's actually defining our first scatter plot using plot. What I would like to look at is the relationship between the miles per gallon and the horsepower of my car. So I'm going to use the plot function. My x will be miles per gallon, okay? And my y will be horsepower. Now, I forgot to define the name of my data frame. So in our case, it's empty cars $MPG for the x variable. For the y variable, y equals to empty cars $HP. And then last but not least, I have to define the type that we've noticed in our help section here. Type equals double quotes and P. If I select this line of code, click Command Return Control Enter, we will see a beautiful scatter plot. A scatter plot in the fourth window. You guys can't see that because my head is over it. So I'm going to zoom in and move it over here. I just clicked on the zoom icon right above my head. My head is probably over it. And then this is the relationship between miles per gallon on the x-axis and the horsepower on the y-axis. So we can see that there is a negative, I want to say, relationship, right? Because the higher the miles per gallon, the lower the horsepower. And that makes sense, because if I want to consume less gas, which is higher MPG, then my horsepower is most likely going to be lower. But if I want high horsepower, a very strong, muscular car, then most likely I'm going to have to pay for gas. I'm going to have to consume more gas. The car is going to be drinking gas like a sponge, right? So it makes a lot of sense. This chart makes a lot of sense. There is a negative relationship, reverse relationship between miles per gallon and horsepower. There is another very, very popular framework for creating charts for data viz and R, and it's called ggplot. Actually, it's been improved, and it's called the ggplot2 these days. So why don't we go ahead and jump into a more advanced, more customizable. At the end, you'll receive charts that are sexier, that have different color coding, that have different styles and aesthetics to it. So why don't we deep dive into that framework right now called ggplot2. I'm going to make a quick comment here in our code, switching switching over to the ggplot2 framework. And the first thing I have to do is install ggplot2. I do it by calling the install.packages function, double quotes, ggplot2. Command return control enter. This is a huge package, okay? It might take some time to install. It also might ask you if you want to install dependencies. You're gonna get a pop-up window in the middle of your screen, like in a pop-up window saying, do you want to install a different package? Then click yes, because ggplot2 has a lot of dependencies. In my case, I had ggplot2 installed already. So it was very fast. As you can see, I got this message that says the downloaded binary packages are in this location, which means that it all worked. I'm not getting any error messages, which is great. I didn't get any warning messages, also great. So I think I'm good to go. So after installing this, I can comment this line out because once I install, I can just forget about it. The second line of code has to be the library function. I have to call ggplot2 into my environment. So library parentheses and ggplot2. Command return control enter to load it. Okay, good. Now that I have this loaded, what I can do is use the ggplot function to create my chart. So you might know this ggplot2 framework, the pyramid, with aesthetics and geometries being at the core, at the base of the pyramid. We're going to actually use those two layers in our ggplot today. And there is more. There are facets, there are statistics, and you can do those when you practice on your own, but the most important here is to define those two, aesthetics and geometries. So we're going to go through aesthetics right now. In the ggplot function, I'm going to first define my data. So data equals empty cars, comma. Now I have to define my aesthetics. So AES stands for aesthetics and parentheses. It's actually a function. And in the aesthetics, I'm going to have two arguments, x and y. I'm defining my x and y variables. Since we've already called the name of the data frame, which is empty cars, I do not need to repeat that again, just like we did with the basic plot function. Okay? So in the aesthetics, it's actually even easier. I'm going to use the x equals mpg, comma, y equals hp. Okay? Good. So we've defined what variables, we've defined the variables that we want to use in our chart. Now we have to tell the ggplot function which chart type we want to get out of this, right? Do we want a line chart? Do we want a scatter plot? Do we want a, I don't know, let's say tree map, right? And here it's more obvious. We have two variables. We want to see the relationship between these two, so we are selecting a scatter plot. In ggplot, that geometry is called geom_point. So we add geometry with a plus sign. After the first line of code that you can see here, we're going to use the plus sign to add a geom_point geometry. And if I run this piece of code, I am going to get a beautiful ggplot chart in the lower right-hand corner window behind my face. And if I click on the zoom button here, I'm going to get a pop-up window with our observations. And again, the MPG on the x-axis and HP horsepower on the y-axis. Same story, negative relationship. But the beauty of this chart is that I can modify it. It's more customizable. I can modify the color of these observations, of these points. I can modify the thickness, the size of it. This ggplot framework is more advanced and more customizable, and that's why it's more popular. ggplot is used more frequently amongst data scientists that use R. Okay, so let's go back to our code. I've closed that window. Let's go back to our code. And this is where I can actually define some interesting elements here. I can say gm underscore point size equals, for example, 0.5. And let's see how our chart will change if I do 0.5. Well, actually, our dots shrinked. They became smaller, right? So that was probably not what we wanted. We wanted these points, these dots to be a little bit bigger. So why don't we do, let's say 1.5 and see how this works. Oh, beautiful. So now we're getting more thick. We're getting thicker points, right? Which makes our chart more visible. However, you might argue that you want to condition the size of this bubble on another variable. For example, the number of gears, right? If we have more gears, we are expecting higher horsepower, probably lower MPG, right? So let's see if there is any relationship over there. So why don't we do this? In the GM point, why don't we delete this in that GM point geometry and instead define more aesthetics. So AES, I'm going to define aesthetics with parentheses for just that one geometry, just for the GM point geometry, just for that one, aesthetics with the size equal to the gear variable, And if I run this piece of code, we're going to get a beautiful chart with the bubble based on how many gears we have. This is really interesting. So it actually is not very intuitive. We are getting a lot of cars with only 3 gears that have a very low miles per gallon and a pretty high horsepower. Really interesting. These could be sports cars, I'm not sure. But then we have a lot of cars that have 5 gears that have a high miles per gallon and a low horsepower. We just defined our size of the point based on a variable. But what if I want to look at the relationship itself, define the relationship, and maybe there is some causation. Maybe there is causation between miles per gallon and horsepower. Maybe I can say that my horsepower depends on the miles per gallon, or maybe vice versa, right? But if I assume that there is causation in this data, causation means that one impacts the other, then we can actually add one more geometry here with the plus sign after gm underscore point and define a gm underscore smooth to draw a regression on our chart. Good. And in this case, we are going to get a polynomial regression with confidence bands. And as you can see, there are some outliers, there are some points, those with very high gear and high horsepower but low miles per gallon that are outside of our regression. But this regression is trying to describe the relationship, the causation between miles per gallon and horsepower. So just another geometry added to our chart to help us better analyze what we are seeing on this chart. I hope this was pretty cool. I'm really excited about this. After this episode, I would really encourage you to try different geometries, try different layers of statistics, facets, try changing the color coding for this chart, play with ggplot. The more you play, the more you learn, the easier it will be to create other charts and answer specific charting needs, because it really depends on what message you want to send to the end user. In our case, the message is very clear. There is a negative relationship between miles per gallon and horsepower. We draw a regression line for all of these charts. It ended up being a polynomial regression, a little bit more advanced. But we also see that there are some cars that are not within a 95% confidence interval. The gray area here is a 95% confidence interval, and we can see that some of these cars are outside of that range. So we can consider them outliers.